today we're going to learn about box plots. Box plots are a way that we can display data visually, and they're a little bit tricky, so make sure you pay close attention and watch the whole video. If you feel confident at the beginning, make sure you just persevere and watch the rest just to make sure. So to begin, I'm going to tell you what a box plot is and what it actually shows. So a box plot is one of the most odd things that you'll see in the world of statistics just because of the way that it looks. It's also called a box and whisker plot, and you're learning it now in 6th grade, but you're going to encounter it again in statistics later on, and also in high school, and most likely in college if you're taking a statistics course, which is a popular choice in college. So a box plot is a display that shows how the values in a data set are distributed or spread out. So what we're basically looking at right now in this section of the module is we looked at measures of center before, the mean, the median, and we even have talked about the range before. This is now going into looking at how our data is actually spread out. So let's talk about what that means as we look at what the box plot shows. So the first thing that you do in order to make a box plot is you have to find a few values. There's 5 of them that you need to know. The first one you need to know is the smallest value or the least value. Then you need to know the lower quartile. The lower quartile is the median of the lower half of your data. Okay, so I'll explain what that means in a second. Let me just see. I can't remember if I typed up. No, okay. Basically, you put your data in order from least to greatest, and then you separate it in half. You find the median of the first half of your data, and that's your lower quartile. And then you have the upper quartile, and that's the median of the other half of your data, or the upper half. Okay? So those are the first. Oh, and I forgot. I'm so sorry. You also need to know the regular median. So those are the first 4, and then you also need to know the greatest value in order to make your box plot. So it kind of sounds crazy right now, so let's just do it together and I'll show you how this works. So we have here our data is the heights of several students, and we're going to make a box plot. So the first thing you do is you put it in order from least to greatest. So my smallest value here is 54. Okay, and then after that I have 56 2 times. Remember, if you have the same value, you have to still list it. And then 58 2 times as well. 60 and 61 2 times. And then I've got a 62. Oh, I skipped over 59. Hold on. Sorry. I knew it was there too. 59, sorry. Then 60, then 2 61s. And then 62, and 63, and 65. Okay? Now, we list it all out like this in order. So now, just by doing that, I have my smallest value, my least value, and my greatest value. So I have 2 of the things that I need now. So I have the least and the greatest so far. Okay? So first things first, you have to find where your middle is, okay? So if you already noticed, this is an even number. So we're not going to be able to cross off until the end like we've done in the past, because what you'll see is we have 2 values in the middle. So we have to find the median by doing the average of those 2, or what's halfway between them. So in this case, halfway between 59 and 60 is going to be 59 and a half. That one's easy to figure out. But of course, if you can't do that in your head, remember that what you're really doing is 59 plus 60 divided by 2. Okay, and you'll get the same thing. Now, this lower and upper quartile business, we have the median. What you do is you split your data in half. So when you have an even number, it's actually easier to see where your middle is, because you just go right in between the two numbers. If it's not even, when you split it up, you don't include your median. Okay, and I'll show you that. So now what we do is we find the median of just this half of the numbers. And this is going to be our lower quartile. So I'm totally ignoring this side. So basically, I'm just going to cover this up for a second to help you see that. So it's going to be an even number again. So you're taking the median here, and 56 and 58, that's easy to figure out the halfway point. That's 57. But again, if you're not able to do that in your head, you do 56 plus 58 divided by 2. Okay, and that's the median of my lower half. Now I go to the upper half, ignoring this side, and I'm going to find the median of my upper half of data. And that's between the 61 and the 62. And again, halfway between those is 61 and a half. Okay? So these are the data points that I need for my data. But I haven't made the box plot yet. I now have everything I need, okay? So this is how you actually create the box plot. The first thing that you do is you have to have a number line, okay? Most of the time the number line is going to be given to you, but sometimes you have to make it yourself. On the test, I am going to ask you to make it yourself, so make sure that you pay very close attention. You create a number line, and you only need to account for the numbers that are in your data set. So you don't need to start from 0 or start from 1 or anything like that. So if your lowest value is 54, you can start at 54, and then you can just go up to where your highest value is. There's nothing wrong with that. So the first thing that we do is we draw points. The first thing that I do is I draw the point where my median is. So my median is 59 and a half. So 59 and a half is halfway between here, and I draw a point here, okay? And this is my median. Then I take my lower quartile. My lower quartile and my upper quartile are going to create a box around my median. So my lower quartile is 57, so I place a dot right at 57, and my upper quartile is 61.5, so I place a dot there. And here's what we do, okay? I draw a little line through each of these like this, and then I connect them like a box. Okay? This is the reason why this is called a box plot. Now, I'm actually not done. I have to show where my lowest and my greatest values are. This box shows where the greatest concentration of my data is. And then I have to show how far down it goes and how far up it goes. So my least value is 54, so I place a point at 54 as well. And what I do is I draw a line like this to show it. And most times that you'll see a box plot done, you will see a line through here. It wasn't drawn in the textbook, I don't think, so I'm showing it to you this way just because it's the most popular way. You don't have to technically draw a line, but I'm going to do it. And then, of course, my greatest value, 65, is over here. Draw the dot. Oh, I made that a little too low. Here. Draw a line to connect it, and draw a little line through it. Now, this is my box plot, which is also called a box and whisker plot. And you can see why it's called a box with whiskers, basically. Okay? So what this shows is a visual way to see where most of my data is. Most of the data is concentrated in this box. So if I look at my data, you can see a lot of it, a great deal of it, is between 57 and 61.5. And the data that's out here is a little bit less. Okay? When you find the lower quartile and upper quartile, you're finding a generalization of what the lower and upper sections look like. Okay? So this is how you do a box plot. It just takes a little practice. It seems like it's a little kooky, but it's really not. It does look funny though. All right, so let's continue. There is something called the interquartile range, and it sounds like it's really horrifying, but it's actually not. The interquartile range is just the difference between the upper quartile and the lower quartile. So one of the things that we look at when we do box plots is the interquartile range. So a measure of spread is a single number that describes the spread of the data. When we say the spread, we're talking about how much it ranges, basically. And if there's any values that are really far away from the center, etc. So one type of a measure of spread is called this interquartile range, okay? And a lot of times you'll just see it written as the IQR, okay? So if you see IQR, that means interquartile range. It sounds like it's scary, but it's not. All you have to do is take your upper quartile and subtract the lower quartile. So over here, I'm just going to write upper quartile minus lower quartile. Okay? That's what you need to know. Don't be scared off by it. It's harder to actually find the quartiles than it is to find the interquartile range. Okay? So, for this example here, what we're looking at are two box plots with the same numerical data here. Not numerical data, sorry, number line. So we have two different groups, and in this case, these groups are comparing the ages of dancers. So this group is a certain data set of the ages of dancers, and this group is a different data set with the ages of dancers. So what we want to do is we want to compare them. So we're going to find the IQR. All you need to do is look at your box plot, and you know that the furthermost line of your box represents the upper quartile, and this one is the lower quartile. So all you have to do is look at it and see what number it corresponds to on your number line. So for group A, the upper quartile is 24, so it's going to be 24 minus the lower quartile, which is 20. So the interquartile range for group 2 is 4. Nice and easy, right? And then for group B, the upper quartile is 26. And we're going to subtract the lower quartile when it's in between two numbers. This is 20, 21, so this is 21.5. Okay, and that will give us 4.5. Okay, and again, of course, if you can't do that in your head, just take it off to the side to subtract. Okay, and like I said the other day, at this point in the year, we're all the way into statistics now. This is the last thing that we're doing in 6th grade math. If you need to use a calculator for something like this, I'm not going to complain about that. So next year when we do 7th grade math, it's accelerated, so the first half of it is 7th grade and the second half is 8th, which you'll be using the calculator for anyway. So it's okay. Anyway, that's how you find the interquartile range. Super easy. Now we're going to try the your turn. So I'm going to have, actually, yeah, we'll do it together. So the box plots compare the weekly earnings of two groups of salespeople from different clothing stores. We're going to find and compare the IQRs of the box plots. So, group A, the IQR of group A is going to be, just follow it down. Of course, I probably should have labeled this. First, you want to check what this scale is. If you're going from 1,000 to 1,500, then these are going up by hundreds. This is 1,100, 1,200, 1,300, 1,400, 1,600, 1,700, 1,800, 1,900, and so on. Okay, so the upper quartile for group A, follow it down, that's 1,800. Minus the lower quartile, follow it down, 1,100. And then, of course, 1,800 minus 1,100 is 700. So, remember, this is the weekly earnings. That's why I'm putting a dollar sign. So, for Group A, the interquartile range is about $700. And Group B, we're going to talk about what it actually means in a second. The Group B, this is halfway between 1,800 and 1,900. So, that's 1,850. And the lower quartile is 1,400. So that is 450. Now, what does this actually tell us? Find and compare the IQRs. What does this actually tell us when we're finding the interquartile range? It's telling us how spread out they are. So the greater the number, the more spread out the data is. So I failed to say that before, that I said that it measures, a spread, but I didn't really say what exactly it's saying. So in the previous example, when we found 2 IQRs, group B had a greater interquartile range. So that means that in group B, the ages are more spread out. And here, because group A has a larger interquartile range, the values in that group are more spread out. That's what it means. Okay? And of course, when I'm saying the values, I'm talking about in the box, not the whole set. And you can eyeball it, so you can tell that the box is larger. It's really something that you're calculating, but you can see in the box, right? Okay, to finish up, we're going to talk about finding the range. Super, super easy. The range is the most common measure of spread that people know what to do, because it's one of the first things you ever learn about when you're doing statistics. You do the mean, median, mode, and the range, right? So the range is just the difference between the greatest value of data and the smallest one. So range, take your largest value and subtract it by the smallest. Okay? I should really be writing greatest and least, but hey, it's okay. Okay? So what we're going to do is we're going to put it all together in one question, which I got from is this from the guided practice? Yes, this is from the guided practice. Okay? What we have here, this data set, are the RBIs, or the runs batted in, for 15 players from the 2010 Seattle Mariners. We're going to use this data set for all of these questions. First, we're going to order them from least to greatest. We're going to find the median, the lower quartile, upper quartile, make a box plot, find the IQR, and find the range. Okay? So, first things first, we're going to put them in order from least to greatest. So, we've got the smallest number here. Oh, sorry, my computer just turned off. The smallest number here is 4. Okay. So remember, if you cross them off as you go, it makes it a little easier. 4 followed by 10 and 11. 10, 11, and 13. I actually don't really need the commas, but you know what? It's okay. 13, 14, and 15. 25, 29, 2 33s, 35, 43, 51, 58, and 64. Hopefully I didn't skip over anything this time. And what you can do is look real quick. You don't have to count here, but if you look, because they told us 15, but if you looked at the numbers, you can kind of tell that it's not even because there's a little bit of a space. But I wouldn't rely on that, of course. Make sure you actually count, or if you're not given the real number of players. So since we have an odd number, we're going to be able to find our median very easily. I'm not going to cross these off too dark because I need to see the numbers still. I'm going to go all the way to the middle and find my median's 29. Nice and easy. Now, like I was saying before, and you're finding your upper and lower quartile for an odd data set, what you're going to do is you're going to not include your median. So you're going to look at this half here beyond the median, and this half 4, 6, 7. Okay, this half here. I just had to make sure I did that right because it looked like it was more, but it's just because this 4 is one digit. So now what you do is you find the median of each of those. So the lower quartile median, you're going to have an odd number still. So you can cross off till you get to the middle. My median of the lower half is 13. So my lower quartile is 13. Upper quartile, the median is 43. So the upper quartile is 43. Okay? And now we can make our box plot. So first things first, I do my median. So I'm going to find 29, which is here, very teeny tiny. And I'm going to draw a dot. And I'm going to do my lower and upper quartiles. So 13 is my lower quartile. So I go over here to the 13. And I draw a dot here. And my upper quartile is 43. So I go to the 43. And I draw a dot here. Okay. And I'm going to make my box now. So I draw a little line through each of these. And I connect them to make a box. Okay. And very important to remember that your median, the line is not always right in the middle of this box. So sometimes it might be all the way off to the sides. Don't be thrown off if that does happen. It happens all the time. If you saw the previous example, group A up here, the line was all the way over. This one as well. Okay, now we need our two greatest and least values. So my little 4 over here, draw a little dot here, draw a little line through it and connect. That's the first whisker, so to speak. And then the greatest value, 64. Go over to 64. Here it is. Draw a line and extend. And there's my box plot. Isn't that delightful? Nice and easy. It's just a little bit tedious to do all those numbers. Now we're going to find the IQR. Actually, something I didn't say, you should always label this like it is a graph. So let's take the title from the data and label it. Mariners RBIs. Okay. Now we're going to find the IQR. So remember, that is the upper quartile minus the lower quartile. So it's going to be 43 minus 13, which is 30. And the range is the highest value minus the lowest value. So that's 64 minus 4, which is 60. Okay, guys? So that's everything all in one problem. Most important thing is that you're able to make the box plot and that you're able to find the IQR. Okay? I know this is very different than what you're used to, so if you have any questions, just let me know. And tomorrow we have a live lesson, so if you have questions from this lesson, you can ask them at the end, okay? All right, have fun with these.